Hi, my name is Scott Klutzer, and I'm the Director of Business Development with LJ Star Incorporated. I'm going to be doing a presentation together that's going to cover some of the challenges that we at LJ Star, as well as our end users, face during the design, selection, and maintenance of some of the equipment that LJ Star does sell, as well as some of the best practices to try to overcome some of those challenges and make it a little bit easier for our customers to determine what may work best in their applications. If you're not familiar with LJ Star, we offer a diverse and innovative range of process observation equipment, which is really what we're known for. Everything from sight glasses, flow indicators, and level indicators, as well as sanitary fittings, LED lighting, and camera systems. Just about anything you would need to observe a process in a facility. We also have a company called Tank Components, which basically the name says it all. They are a producer of tank heads, manways, sanitary fittings, cylinders, and custom applications. So we play a pretty significant role in supplying all sorts of equipment for use in the process industry. I always like to start off most of my presentations by asking, why glass? That's basically what we're known for. So I'm going to try to get into some of the reasons why a customer would want to look at using glass in their applications. So optical clarity is one of the main reasons why glass. It's clear. You can see through it. It's why your house has windows made of glass so you can see through it. It's why your car has glass so you can see through it. It's going to basically enhance your ability to view the process safely and in process, which is very important. The best example I can give for anybody that's not necessarily in a process type environment is if you're at home and your hot water heater isn't working properly, the first thing they tell you to look at if you've got a gas powered water heater is whether or not the pilot light is lit to make sure that it's functional. You would look underneath the hot water heater and you'd see a small clear glass or plastic covering that allows you to see in underneath the unit and verify whether or not the pilot light is lit. That is probably one of the easiest examples I can give you of why you want optical clarity, to be able to see but separate you away from what that process might be. The other important thing is when you get into internal inspections, you've got possibly high pressure applications that you can't just open a process while it's actually functioning, because it could cause harm to the operator. So you may have a high pressure application. You may have high temperature applications, or even very, very cold applications that could cause harm to the operator, but they need to be able to see what's happening inside. And that's what glass does, is it allows you to see inside without having to open a process. As far as visual backup, we're seeing more and more new technologies such as radar, allowing the operator to sit in a control room and determine what the level of the tank is, for example. One of the things we run into all the time is filling and loading and unloading of tanks, and they need to be able to know how much, because they may be loading from rail cars or dairy trucks, and they need to know exactly how much is supposed to be going into that tank, because it may not be the same size as the rail car or the dairy truck that's actually loading that tank. So they would use some sort of a radar or whatnot, and they'd have it in a control room. But the problem with that is those don't always work. I would like to say that they do, but they do have issues where they may be inaccurate. They may not be reading right. There may be something interfering with the reading, like there may be some sort of foaming that they were not expecting inside the tank. And because it's not reading right, they need a visual backup to that newer technology. And that allows the operator to verify what they're seeing from their radar or whatever device it may be in the control room is accurate, and what they're seeing inside the tank. So there may be some level gauges on the outside of the unit. There may be a sight glass that they can view inside to make sure that it's not getting towards the top of the tank. Because I have seen time and time again historically where companies have overfilled tanks because they've relied too heavily on some of these newer technologies. Some of those materials that they were loading are considered by the EPA to be dangerous. And when they have a leak and it gets into any of the drain systems at the facility, they have to write significant reporting. There could be fines to the government. Whatever it might be, this visual backup is a great way to verify that these newer technologies are functioning properly, and in many cases are required as a second and a third inspection method. With regards to corrosion resistance, we have all kinds of different glass materials that we can use to meet different customer needs, whether that be something that's very caustic, something that's needs to be a little bit more resistance to chemical attack than the materials of the tank, for example. Some cases you'll see glass used in glass-lined tanks just to protect the metal from the corrosive properties, because many of the glass materials are so good at dealing with corrosion. Temperature is a good one. We can pretty much cover any temperature range depending on the type of glass. And I'll go a little bit further into that, but we can meet very low temperatures. We can meet extreme operating conditions where you have very, very high temperatures or temperature requirements. And we have various materials that can be used to meet those requirements. And then we have affordability. I like to bring up affordability because I think that compared to other materials of construction that offer, similar properties where they can deal with very high temperatures or you can deal with various caustics, I think glass is very affordable. I think it's relatively inexpensive and a very simple way to allow the operators to get a better understanding of what's going on with their processes. In this next section, we're going to talk a little bit about some of the challenges that we see in sight glass selection, try to cover some of the questions that we get from some of our customers, some of the engineering firms that we work with, and try and work through some of those. Below, I've laid out some of the challenges that we face when helping our customers design a specific sight glass for their process. The first one that tends to come up is compatibility. We want to make sure that whatever we're quoting is compatible with the process, and that can be everything from temperature to whether it's corrosion resistant to whatever it might be, but we want to make sure that all the product that we're putting together to form this one piece of equipment is compatible with the process media that the customer has. Now, in this case of compatibility, we are not at liberty to give a recommendation on a specific material because we just don't know enough about our end users' process media to make that kind of determination. So we're going to have to rely on our customers to have an understanding of their process and help us determine what materials may work best. So if they say a 3/16 stainless steel is acceptable and this particular gasket material, then we can go about designing the sight glass around those requirements. So we're going to need to know what type of compatibility we're looking at with the process media that the customer has. We're also going to need to look at other things like operating temperature and pressure range. Each of those can impact each other and are very, very important when we're working through a design for our customer, because the operating temperature is important because we need to know what materials can withstand that. We've had some customers come to us saying that they want units in excess of 1500 degrees. We've had some come saying that they want to meet cryogenic application requirements. Those are all going to have an impact on what temperature the materials are good to and what pressure range the unit can be rated to. We also want to talk to our customer a little bit more about the visibility requirements. And this one doesn't come up as much as I would like it to, because a lot of times it's an engineer designing for a maintenance person. And I tend to find there's a little bit of a difference between the person maintaining and operating the equipment and the engineer sitting up front that has not come back and actually talked to the maintenance team about what they want to see. So in many cases, I like to try to have a conversation and understand, what are you trying to view? What are you looking at? What is important to you? So not only can we determine where the sight glass may best be fit, but we can also determine maybe there's a camera system, maybe there's some LED lighting that's required because it's dark inside the tank and they're trying to see further down, or they want to see close, or whatever it might be. We kind of want to get an idea of what those visibility requirements are, because it may require a circular glass, it may require a obround or a longer one down the side of the tank to determine just level. But visibility is always very, very important and can dictate a lot of the conversation when we're looking at various designs and what we can offer. Now, material selection, of course, once we've gotten through compatibility and we have an idea of what we're looking at, operating, temperature and pressure, and maybe visibility, we can look at material selection. And again, this is going to come down to what the customer determines is allowable in their operation. So we want to look at whether they want composites or metals, and it might be dependent again on what that compatibility is with that process media. We're going to want to review gaskets because we have a sealing gasket which is wetted. We have a cushion gasket material. We want to make sure that those are acceptable. And then we're going to get into some of the see-through materials like the glass, the polycarbonate, and acrylic. And those can change because when we're dealing with a pharmaceutical application, normally they want some sort of a glass and a higher end glass because it's inert, it's not going to leach. Whereas when we deal with a food and beverage customer, they may want a polycarbonate or an acrylic because they cannot allow having glass in the facility, because if it breaks and it gets into a batch, it could cause some real issues. Whereas the polycarbonate, acrylic, or even some other materials that they can actually detect in their systems may be required. So that's another area that we want to have a conversation. And then again, we look at, what's the size, what's the shape, how is it mounting? We want to go through some of those requirements and determine what type of a connection, whether it's bolted, threaded, or welded, and are we looking at a circular or an obround or a rectangular, or is it a level gauge that comes off the side of the tank and isn't even mounted to the tank other than just through some connections and some valves? There's a lot that we have to go through to determine what's the best fit for our customer. Now, based on some of the challenges that we just talked about, those are all the things that we'd really like to have figured out. But in many cases, our customers don't always know. They may be at the start of a project and they're trying to get some pricing and determine what is going to be required with regards to their sight glass and what can we do for them. So what we like to go back to our customer and say is, look, for us to be able to tell you what we recommend or what may work in your application and give you some sort of a budget price or a standard price, we're going to have minimum design requirements that have to be met. So when you come to us for a quote, we have to know these key items that I've got listed here. So we need to know, what are you trying to view? What's important to the operator? What do they want to see? Are they trying to see level? Is it flow? Is it foaming? Is it color? Is it particulates? What are they looking for? What are they trying to view? So we know if a light is required, so that we know if all we're looking for is level. Is it flow? So there's different styles of sight glass for each of these applications. We love to have this information. We could probably get by if you have just some sort of an idea. It doesn't have to be perfect. But what we do need to know for sure is, what type of mounting or connection type are you looking at? Because we can't price it if we don't know, because there's so many different types of mounting and connection types. Is it going to be welded? Because there's a different process if it's welded. Is it going to be bolted? Because we've got to match whether it's a 150-pound raised face. Is it a 300-pound raised face? We've got to know what type of mounting and connection type you're looking at having used with this particular application. What are the process conditions? Now, these are must-haves. I mean, we get requests all the time, and we're told we just want a sight glass. We want it on a 6-inch fitting. Please go ahead and quote that. And we can't quote that because we don't know what that pressure is. We don't know what that temperature is. We don't know if there's any type of caustics present, so that we know what materials are going to be accepted. We have to know what the process conditions are. At minimum, we have to know pressure and we have to know temperature. And again, we also have to know what size you're looking for and what type of connection. Those are the key items that we have to be able to at least get you started and start moving you in the right direction. Because if we don't have pressure, we don't know what to design to. We don't know how thick to make the glass. We don't know how thick the weld pad or the mounting pad is supposed to be. We don't know, necessarily what type or size of bolting is going to be required in the design. If we don't know the temperature, again, the temperature is important because that can dictate what the pressure is. If we're dealing with a ASME rated unit, as the temperature goes up, your pressure comes down, and we have to be able to design to what that maximum would be at whatever that higher temperature is. Most cases when we get a job from an engineering firm, we're going to have a minimum, we're going to have a maximum, and we're going to have an operating. And in many cases, it's interesting because we can easily achieve the operating requirements. You know, it might be something simple like 20 psi at 200 degrees, but then they're going to have a maximum normally where they have a worst case scenario, and it might go to 800 degrees and 150 psi maximum. And in that case, we may have some issues, because if 800 is all of a sudden your maximum requirement, you've exceeded the temperature requirements of our standard glass, and we would have to move you into the next step up, for example. So having pressure and temperature are two of probably the most important requirements when we're trying to assist you in designing a sight glass. And then what materials are going to be required? Again, that's going to be dictated by what we find out on the pressure, temperature, and whether you have caustics, because then we could look at composites, or we can look at different metals, and depending on what level of caustics we have to be able to handle, you may want a 316, or you may have to go to a Hastelloy, for example. Then we can look at gaskets and make sure that those are product compatible. And then we can get into glass, whether or not the standard glass would work, or if they need a polycarbonate or an acrylic. But basically, the materials are going to be driven by what those pressure and temperature conditions are. So those are extremely important, and these are what we require when you come to us for a quote and want to have a conversation about what we can and can't do for you. If you don't have these basic requirements laid out, then we're most likely not going to be able to help you. And we do run into a lot of issues where customers just don't understand why they can't just give us why we can't just give them a quote for something if they just give us a size and say they want this. We really have to have those pressure and temperatures to make sure that that unit is going to meet the customer requirements. This next section is going to be kind of a piggyback on the previous, where I'm going to get a little bit more into the material types and connection styles, just to kind of give you an idea as to what we're able to do. So there are a significant number of connection styles. I probably can't even name most of them, and new ones are popping up here and there all the time. But they can vary by industry and application requirements. So industrial, for example, I tend to see a lot of bolt-on, may get into some weld-on for the tanks, and then threaded fittings. And you may see those whether it's an inline flow indicator or a sight glass that's being mounted on a tank, or even on a level gauge that's mounted off to the side of the tank, where it could be threaded, it could be bolted, but you see that type of fitting more or less in industrial. And again, there's probably quite a few more than just these, but these are basically the standard ones that we would be able to quote on without really having to go out and have something made special to fit a different type of connection. Same goes for food and beverage. You're going to get a little bit more into more of a sanitary fitting. So you may see some more tri-clamps, you may see an eye-line, a weld-on, threaded, depends on where it's going in those applications. And then in sanitary, where you get into pharmaceutical, you're going to see a lot of sanitary tri-clamp fittings. You'll see a lot of weld-in, not as much bolt-ons because they don't like a lot of threads in sanitary connections, so you'll see a lot more of the weld-ins or the sanitary tri-clamp fittings, and even some other sanitary fittings that I'm not listing here. So there are quite a few different connection types. But just for us, if you're coming to LJ Star and you're looking for what's the standard, you'll see a lot of these type of connections. And then again on materials, again, it's going to be based on application and market type. Materials are, I hate to say it, I love selling out of our catalog where, we've got, we do a lot of carbon steel, we do a lot of 316 stainless steel, but then you've got the AL6 and you've got the Hastelloy and the Inconel and the Monel and the, you name it material wise, and there's new materials being created daily that I'm not even aware of in some cases. So they can vary widely, and I definitely would like you to know that we can pretty much get just about any material that a customer may need. But what we tend to see is, industrial, we tend to see a lot of carbon steel, stainless steel, and brass. When we get into food and beverage, we may still see some brass, but they tend to get a little bit more into the 304 or higher, 304, 316. Those are usually acceptable materials and pretty standard for LJ Star. And then when we get into sanitary, we're looking at 316 or higher. You don't see much 304, but you do see a lot of 316. You may see AL6, you may see duplex. They require a little bit higher corrosion resistance in the sanitary markets compared to, say, the industrial, where carbon steel may be acceptable in a lot of the applications. And the other big difference you're going to see in materials as well is, in industrial, for example, you're not going to see a lot of documentation requirements. You may see some MTRs tied to heat numbers on some of the equipment, but when you get into the sanitary, pharmaceutical definitely will require full documentation on all materials. Normally the materials are going to have to be heat marked, they're going to be traceable. It's getting that way more and more in food and beverage to where, it's going to require some documentation, not as much as pharma yet, but it's there. And those are some of the differences that you're going to see when you're dealing with the various materials that can be used, as well as the different markets that those materials may be used in, just to kind of give you an idea on, especially on what we're seeing in the marketplace. So most people tend to be familiar with the different metals and the different gaskets, but I'm going to talk a little bit about the standard glass and try to help you understand a little bit more about probably the most important product that we sell, because that's what you want to see through, and that's the glass. So we have to try to make our products compatible with our end users, and there's different grades of glass that can be used for each of those different applications. So to start off, we start with Boro Plus, which is kind of that entry-level glass. It's similar to soda lime, but for example, it's less resistant to thermal shock. It leaches a little bit more when you start to get into a process that might be a little bit more corrosive, which is not what you want to happen. So the Boro Plus is kind of that entry-level glass. Then we go from Boro to soda lime, which is probably the most common glass that everyone is aware of for non-processing, which would be like 90% of glass manufactured. So it might be, when I say non-processing, it might be used for glass in your car, glass in the windows in your house. It might be the glass used in the Sprite bottle that you had at dinner the other night. It's also extremely recyclable, so it's relatively inexpensive. That's why it's easy to manufacture. It's a very common material, and it can be recycled. So you see a lot of soda lime in and around the marketplace. Soda lime's got quite a few positives, but it also has some negatives as well, and durability being one of them, because it is a softer glass, because it's easier to cut in production. But that means that it's less scratch resistant, for example. Thermal shock is a bit of an issue with soda lime. The maximum operating temperature, for example, of soda lime is 300 degrees Fahrenheit. And with regards to corrosive environments, it's okay, but it's not great, and we don't recommend using it in non-corrosive environments, or in corrosive environments. Now, with regards to the next step up, which would be the borosilicate, which is what LJ Star normally recommends as your starting point, and the reason we do that is because it is a superior glass to the soda lime and the Boro Plus. It's got better durability, so from a glass hardness standpoint, it's stronger and more durable. And on the mineral hardness scale, for example, with soda lime, most soda lime is going to be a 6 or less. And with regards to borosilicate, you're looking at a 7.5. So it's a stronger glass. It's got better thermal shock resistance. It's better at withstanding corrosive environments. because borosilicate glass resists chemical and, say, acid degradation, you don't have to worry about products seeping into your process. So a lot of pharmaceutical companies will use it because you're not going to have leaching of glass into the process, which is extremely important because you don't want a contamination. So borosilicate is a higher grade glass and where we normally recommend you start with. Then you get into the specialty glasses like the quartz and the sapphire. Now, reasons why you would get into quartz and sapphire. Normally, we get into quartz because it's able to withstand extreme temperatures of up to, say, 2,000 degrees Fahrenheit. You can literally take quartz out of a red heat and plunge it into water without cracking the glass. So it is made to withstand extreme temperatures, and that may be where we use that. Also, it's got good chemical resistance, not as good as sapphire, but good. And it's got a wide optical transmission band, which is really the other area that we use it for because it can allow UV and mid-IR to pass through the glass relatively easily. So for us, the two main reasons are going to be temperature and it's going to be the optical transmission when we go to quartz. Then we have sapphire, which is the premier glass across the board. It is chemically unreactive. It resists nearly all chemical attacks. So when I get into very difficult situations where you may have hot caustics where you've got high temperature and caustics together, which make it even worse. We find that sapphire, I can't say in every application, but in just about every application I've ever worked on, is chemically unreactive and resistant. We've been able to use it in applications that no glass has been able to be used in the past, and still allow the operator to see inside that process, and they have been very happy with the results using the sapphire. It's extremely hard, which is great because it allows us to have a little bit of flexibility in how we use it. Normally I would use sapphire as a shield against my standard glass because it is so much more expensive than standard glass, but that is because it is so hard. On a mineral hardness scale, sapphire comes in at about a 9, while diamonds, for example, have a hardness of 10. So normally, to get a sapphire piece optically clear, you would use some sort of a diamond bit to actually polish the sapphire because of how hard it is. So we tend to use it as shields. It's also an excellent product when we're dealing with optical transmission as well, similar to the quartz. It has a very wide, much wider optical transmission band for UV to mid-IR than even the quartz glass does. The other way I like to look at the various glasses is if you are someone that likes baking, for example, and you have an ingredient list or you have a recipe. And the way to look at this is when you start creating your recipe, you may start with just a plain sugar cookie, which would be Boro Plus. Sugar cookie's okay, it's nice, but it's plain, it's bland, it's everybody has a sugar cookie. But what you do is you start modifying that recipe. So you may change some sodium oxide, you may change some magnesium, you may change some aluminum oxide, some silicon dioxide. You start modifying that recipe similar to how you would with cookies. You add some chocolate chips, you add some additional brown sugar, you add whatever it might be. But whatever you're adding gives different strengths to each of the glass. So for example, with the borosilicate compared to the soda lime, you may be adding some boric trioxide that would give it some of the additional capabilities of thermal shock. So that's kind of what happens with each glass. There's a little bit of a difference in how those are made up as far as their ingredients and what benefits that they're actually going to have, whether they've got better thermal shock resistance, whether they've got better resistance to caustics, whatever it might be, whether they leach, whether they don't leach. It's all going to come down to how those glasses are made up, what the ingredients are, and what they've added to those ingredients to give them those benefits within the glass. In this next section, we're going to look at some of the challenges in sight glass inspection and maintenance, which are extremely important and not talked about enough. These are some of the challenges that we've seen over the years working with some of our customers. And just to go over some of these, but some of the main ones would be misalignment and installation errors. And we run into this quite often because, you're trying to put the unit together and you've got your base, you've got your gasket, your glass, your cushion, your cover. Everything has to fit properly and go together properly. So if you have any type of misalignment or installation issues, you could see leaking at the connection. You can damage the glass or the gaskets when you put them in. You can have gasket intrusion. So misalignment is extremely important, and it needs to be taken seriously when installing a lot of the sight glasses. The other thing is corrosion, having customers not understand their materials. And as I mentioned, we can't make recommendations with regards to what materials a customer should use because we're not familiar with the process. So we always recommend that our customers do a little bit of research and make sure that the materials that they're requesting can handle the actual application or media that it's having to see. So you don't have these corrosion issues, because with corrosion, you can have corrosion attacking the metal and leaking through and getting out. You can have it attacking the gasket, the glass, whatever material may not be suitable for that process is the one that could fail. So you have multiple failure points with regards to a sight glass. When dealing with cracks, chips, and scratches, this sounds funny, but I've been on site over and over again, and normally on a tank you have a dome top, and because it's domed, there's not a lot of areas that you can set tools. And I've seen time and time again customers, maintenance, whatever it might be, setting their tools on the sight glasses because that's the flat point at the top of the tank or the manway or whatever it might be, and that causes cracks or chips or scratches, and any of these can reduce the ability to hold pressure and lead to a possible failure. I always like to tell people when I'm talking about glass that the way we cut glass is we basically score it. So we're putting a scratch on the glass and then we're putting a bending moment on that glass. When we put that bending moment on that glass, the glass fractures at the point that that actual cut has been made. And that's what can happen when you're putting a whole lot of pressure behind a sight glass and you've got a crack or a chip or a scratch in it. Contamination is another one that comes up quite often. This can create issues with batch taste or even cause complete batch failure. If you are not making sure that the glass is acceptable for the application, you could have leaching from both the gasket that's not acceptable, or you could have it from the glass, as mentioned. If it's being corroded, it could be actually contaminating the process in smaller batches. So that's definitely something that we like to look at. And then leaking can be costly and cause production loss as far as batch loss, because if there's a leak and a drop gets out, the theory is that doesn't mean that something couldn't get in. So especially in like a pharmaceutical or a food and beverage, the last thing you want is something leaking, because it could lead to some sort of a contamination of the product that's being produced. Inspection and maintenance is extremely important and something that I really stress to our customers, because regular inspection and cleaning of the sight glass should be done to make sure that when you do your regular inspection and maintenance, that you can actually properly see the sight glass and that it's well maintained, and so you have some sort of an idea of what's happening over time. I like to see an inspection and cleaning schedule. I know that not everyone does it, but I highly recommend, as does LJ Star, that you have a regular inspection period with regards to cleaning of the sight glass. Scheduled inspections are great to make sure that the glass is inspected for cracks, chips, scratches, whatever might be going wrong with it as far as imperfections. It's something very simple where the user would go out, they would look at the glass, they would basically take a light and put it at an angle to see if there are any cracks or scratches, and that can happen quite easily with glass. It's not impervious to being hit. There's a lot of operators that are moving in and around where they may set tools on it, as I mentioned earlier, or they may bump a glass during production or during maintenance of other equipment. So it's something that really should be checked, especially since it can be broken. I would also look at making sure that you check the glass for any type of erosion. It's good to have some sort of a scheduled replacement plan with regards to the glass and gaskets to make sure that they're kept in good shape. I'm not saying that all glass will erode, but normally, if you've got some sort of a corrosive product, even a product such as a CIP process, where even though the borosilicate glass should be good for a CIP process, if those caustics get too high, it could start to attack that glass. Or if there's cracks in the glass that allow a starting point for that corrosion to occur, you want to be able to see that. So you know that if you're having to withhold a certain amount of pressure, if you start to lose a certain amount of thickness of that glass due to erosion, you want to make sure to get that replaced in a timely manner so that you don't have any issues with the sight glass breaking. You want to also inspect gaskets and seals. You want to make sure that when you're looking at those gaskets that you don't see any drops of fluid. It's pretty easy to see if there's a leak. In many cases, you'll see something as simple as just a small drop of fluid around the gasket. You may see something a little bit more of a flow instead of just a drop, but you want to make sure that there is no leaking whatsoever or wetness around those gaskets and seals. And again, it's pretty simple to just go up and look once a month, twice a month, and verify that there is no signs of leaking or wear. And you also want to ensure proper installation and alignment of the sight glass. So if you are replacing these components, you want to make sure that when you replace them, that you clean the sealing surface fully. So many times you'll take the gasket and the glass out. The gasket may leave remnants on the counterbore where the glass fits. You want to make sure that you get all that removed so that it's a completely flat surface. You want to make sure that you get everything aligned properly, and you definitely want to make sure that when you're actually tightening the bolts that you use a tightening sequence, because you want to make sure that the flanges are brought together slowly and that they are always in parallel when you're tightening that unit back together. And essentially that means that you start by using the correct bolt tightening pattern that is listed in in any of the manufacturer's installation and operations manuals. And then you want to tighten that pattern at a partial load, and you want to do that multiple times until you hit, increasing every time until you hit the full load, so that way you keep a nice, even, parallel mounting surface and not cause the glass to break or the seal to not seat right. That way you make sure that everything is how it should be. And all of these notes are going to be found in the installation manuals. And if you ever have questions, like you don't have the installation operation manual on site, if you contact LJ Star, we're more than happy to send that over to you. And then you can use that to determine what your torque sequence is, what your torque requirements are, as that is normally based on the gasket that you're using in that application and listed within the booklet that we send out. But we like to try to make sure that you have as many tools as possible with regards to your maintenance, to your installation, to your inspection. And we're more than happy to walk you through what you should be looking for with regards to inspection as well. So feel free to reach out anytime and talk to us about it. So just to do a quick review of today's presentation, sight glasses play a very important role with regards to being able to observe and inspect safely a process at a facility. As mentioned before, you'll find that sight glasses can be used as a secondary source with a lot of the newer technologies, but that sight glasses will allow the operator to see what is happening inside their equipment. And I have found time and time again, they have saved a lot of time in understanding what may be occurring inside the tank and what may not be occurring as it should be inside those tanks. Also, I hope what we reviewed with regards to selecting the appropriate sight glass, type, material, size, and shape made sense. If anyone has any questions with regards to that, please feel free to ask at the end of this presentation. Those are all very important when making sure that the sight glass we are offering you fits all your functionality and requirements that you may have at the facility. So certainly I hope that some of those items to think about definitely made sense, and that in the future, if you do need anything, we can kind of work through those to get you what you need. And then I see this all the time, and LJ Starr and myself think this is extremely important, but facilities really need to take inspection and maintenance seriously with regards to sight glasses. It's not any different than the pumps or the valves or the piping or anything else that you're inspecting at the facility. These inspections are necessary to make sure that you don't have leaks, that you're not contaminating any of your process, that you're not going to have any failures of the unit itself, especially when it's under pressure or temperature or anything else that we discussed. So please feel free to ask any questions after the presentation. If there's anything that we can help you with, LJ Starr has a phenomenal team of inside and outside sales representatives that are willing and able to answer any question you may have. We have an outstanding engineering crew, and we have just a phenomenal group of people at the company, from order placement all the way through that order shipping to you. And anyone that's worked with us in the past knows this. So if you have any questions, please feel free to stick around afterwards and ask me anything that you may have.